Hello everyone. Today I'm going to talk about thrust load in pressure pipe design. You see different scenarios in piping, and just I need to mention at the first that it should be pressured or pressurized piping system, not gravity system. When we have different situations like bending or like something changes in the direction of the pipe, like reducer or dead end like this one, or T-section or T-junction we say, or just Y connection, there are some changes in the direction of the pressure. We have VQP, velocity, debit, and pressure. Due to changes in this direction, mainly we have change of the load. We have some loading, that the reaction load that pushes the pipe. We call this load as thrust load that should be taken, and the piping system should be protected against that one. So let's have a brief description of this thrust load. So thrust load is in piping system, in line direction, and it is definitely in pressurized pipeline system due to changes in fluid pressure or momentum, and it occurs at points of change. Change can be bend, fittings, valves, direction of velocity changes that creates an unbalanced force that can cause joint separation or pipe movements. So we need to design a truss block or anchor block to take this unbalanced force that's called thrust load. So this thrust load is countered by anchors, truss blocks, or restraint joints to prevent system damage and maintain stability. That's the whole idea for thrust load design. This is a general shape for thrust load. You see it is dead end here. The right side is dead end, that in a pressurized system, and the other one is just like something like, and the left side is like something like 90-degree bending, that we have changes in the direction of the fluid or flow, and we need to take care about the pressure and the thrust load to avoid any damages in the pipe and movement. So again, just different situations: bend, reducer, dead end, T-junction, and Y. And here at the end we have different scenarios for the thrust block to take this load. Top left is just normal bend, second one is T-section, third one, or the right hand side, is dead end, and the bottom left is vertical thrust load. Just to mention that here, thrust load doesn't need to be always horizontal. We may have vertical, same scenario, same principles for the load due to changes in the flow direction, and also gradient thrust. We have some sloping system or sloping ground, and we need to have some pressurized pipe crossing that one that causes thrust load, and we need to take care about that one. See here are different, and the other parts I'm going to take later. In general, we do truss blocks without reinforcing. I will say why, but remember, it is just something like unwritten principle for all designers, because the designers for this piping system are always just mechanical or process guys, but the truss block design is something structural, and we need to take care about this one. But in general, everyone's believed that thrust block, especially when it is in normal bend on T-section or dead end, should be unreinforced. But still it depends. It may need reinforcement or it may not. This is just some situations where we need truss blocks. This is anchor block, and definitely we have something like flanges or just some changes or just stoppers in the fluid direction, and that causes a big truss load and we need to take that load. And here same, we have some changes in the size of the pipe or the size of the pressure, and we need to care about that one. Here just on the left side you see that there's a big truss block to take care or just to react against the truss load. Here a different type of truss block. You see that we have some piping system. It is going to have some flanges or just stoppers in the line that when it is stopped, the pressurized fluid just causes a big truss load, and we need to have some truss block system to take that load. And here again on the right side there is a change of direction of the fluid, and definitely it is causing some truss load, and it will cause just lifting up this pipe, and we need to have some encasement for that one or truss block system to prevent any damage or just uplifting the pipe system. And this is just something like reactions with that inward outward when we have change of direction of the fluid. And here again we have just, it is just some anchor block and penstock, and you just see that's the main reason why we have truss load here. The penstock causes the truss load, and we need to have anchor block or truss block to take that load. And here there are different systems to take the load. Here the first one, A, is just say we have bend in the direction of the fluid, so we have some here, it is truss block that takes the load. It is like something like cushion or just support to take the load and transfer to the soil here. And same here, it is like something like vertical bend that causes lifting up the pipe, and we need to have something heavy to take that piping system down, and we need to anchor it to the piping system. So changing the direction of the fluid here, just lifting the pipe, but this gravity system pushes it down. And same here, we may have just some pushing up system, and number C, pushing up load, and we have some gravity or just heavy item here, and we have anchor to the piping system. It holds the whole system down and prevents truss load damage to the system. So here different types of truss blocks and anchor block. Yeah, here's our anchor block. We generally, when we have the anchor blocks are generally reinforced, and truss blocks can be reinforced or unreinforced system. Yeah, just you see we have just some stoppers here, reducers, and we definitely need some truss block here, anchor block here, and that is the main idea. And I'm going next to see what we exactly need to design this anchor block. This is a cross section of the long section. This is the long section of the pipe. The pipe is here, and around is reinforced concrete block that is just somehow it is embedded in the soil. The load on this direction, let's assume that the load is in direction. The load is in this direction, pushes this system, this point. So we're creating this anchor block like this, and part of this anchor block that is in contact with soil transfers the load to the soil. So the soil should be strong enough to take that load. That's called serviceability. And the other system, and the other issue here is we have the big load transfer to this anchor block, and anchor block itself should be able to take the truss load. So we're going to define the thickness of this one and what reinforcement we need for the load we have. And remember, for the first part that we're going to check against the soil capacity, we always use service limit, that is the truss load is unrev and unfactored. But for the design of this concrete block, we're going to have just a factored load, and the same principles that we're using for, let's say, just bending system or just shear transfer system. It is factored load, and also we decrease the capacity of the system to design. That is the general things, and same here. And the last thing I need to just mention here, just here, after all, you need to have something strong enough to connect. It's like something like hinge or anchor. You need to have some connection between this pipe and this anchor. It's like a key. This key transfers all the load from the piping system to the anchor block, and anchor block takes the load and transfers to the soil here. And depending on the geometry of the site, we may have just this type of system. It can be just the soil here and anchor block, the concrete part here, and it should be just connected or anchored to the system here. And that's called like this. And definitely in these situations, in most of the case, we need to have reinforcement for bending and shear capacity of this concrete block. Yeah. And another part is just a very popular in design. It is plan view, and this one is just some slight bend, and we have truss load in this direction. So we need to have something concrete part here to take this load. If we have space, we just put some concrete block to transfer the load to the soil. Otherwise, we need to have some encasement that takes the load, but itself should be heavy enough to acting with the friction with the soil or interaction with the soil to take the load and stop the movement, and also take the load itself. In general case here, because it is just something like bending section, we need to have reinforcement all around the pipe because it is bending system. And it's like an encasement. It should be heavy, and also it should be strong for bending to take the loads. And same here, we have similar items. It is truss block here, and it is encasement here. Encasement means that we are not able, we can put some truss block here, but in general case, because we have uplift here, we're going to encase like this in some specified length. The weight of this concrete should be strong enough to prevent uplifting of this one. It should be just like against uplifting pressure, and also the body of this, or the skin of this concrete encasement should be strong enough for ultimate design. So we're going to provide some reinforcement for any shear or just bending that happens on the skin of this encasement. So the last part, it is some very basic and general general principles to design truss block, anchor block. You know that there is no specific design code, or just the literature is very that is sufficient for truss block design, because it is just something like general. It relies on the basic principles, but we need to make sure that the basic principles are all met, and we are confident enough to take the serviceability limits and the ultimate state limit. So the main question here, when we're going to design truss block, let's say we have just something like pad to transfer the loads from the piping system to the soil. In this case, the backside of this truss block is the contact point with the soil. So we have a load here distributed on this back system area, and if the load on the area is less than the capacity of the soil, bearing capacity of the soil, we say it is enough. Remember, bearing capacity in horizontal direction is generally about half the bearing capacity of the soil in long direction. Let's say if we have 100 kPa for vertical bending capacity of the soil, we always consider about 50 kPa for horizontal bending capacity. So if let's say if we have 200 kPa truss load, kilonewton truss load, and applied on this area, if the distributed pressure is under 50 kPa, we are safe for distributing system for truss block area. Otherwise, we need to increase the area of this one, or we need to strengthen the soil to have higher bending capacity. And the next question is that, do we need reinforcement for this one? It is easy to check, because this type of anchor truss blocks are thick enough. The only way to check this one is check for shear, punching shear. You know that the punching shear check is always two parts. One part is for reinforcement, the other part is just concrete itself. In this case, we check for concrete, bare concrete, or only concrete case. And if it is strong enough for this one, we say that the concrete itself is strong enough. Otherwise, we need to provide some reinforcement like what we design for slabs, or just the columns above the beams. So it is easy to check. First, you go for unfactored load for serviceability area, or transfer the load to the area behind the block. If it is under the bearing capacity of the soil, we say it's enough. The other part is just we increase the truss load and check with, actually we're going for ultimate load, and we're checking with the punching shear of this unreinforced concrete block. If it's okay, we say the unreinforced concrete block is strong enough for serviceability to transfer the load to the soil, and also itself can take the loads. Otherwise, we need to put some reinforcement. Okay, that's very simple and basic principles for truss block design. Just remember, it is very basic, but always make sure to check step-by-step rules for truss block design, anchor block or truss block design. You rely on the bearing capacity of the soil, horizontal, vertical, and if we have uplifting, in general, we rely on encasement. The gravity of the encasement should take the piping system down. And encasement system, in most of the cases, we have reinforcement, but in cases like this, we may need reinforcement or we may not. Thanks for your time to watching this video. Please share your comments about the issues you may have for punching or just a truss block design. I've tried to give you some practical problems, or just some real projects that I've already worked and it's already constructed. Thanks. Bye.